CLE Computer System Servicing Week 4 is all about calculation and mensuration. At the end of the lesson, the students should be able to select measuring instrument, carry out measurements, calculate, and maintain measuring instruments. Components and objects to be measured. Memory is a component in your computer that is used to store data and instructions. Computer memory is the storage space in the computer where data is to be processed and instructions required for processing are stored. RAM, or Random Access Memory, is a temporary memory. The information stored in this memory is lost as the power supply to the computer is turned off, also called volatile memory. It stores the data and instruction given by the user and also the result produced by the computer temporarily. So remember, once the computer is off, everything will be lost. That is RAM. ROM, read-only memory. Information stored in ROM is permanent. It holds the data even if the system is switched off. It holds the starting instruction for the computer. ROM cannot be overwritten by the computer. It is also called non-volatile memory. So the difference between the RAM and the ROM, it holds the data even if the system is off. Whether you turn the computer on or off, the ROM is still there and cannot be overwritten. Storage drives. These are also known as secondary memory that are used for storing data or information permanently. We have data storage capacity. The amount of data a storage device such as disk or tape can hold. Storage capacity is measured in kilobytes, megabytes, gigabytes, and terabytes. Magnetic storage devices. Floppy disk drive is a removable disk drive 5 1/4 or 3 1/2 in size that is used to save data between 1.2 MB to 1.44 MB of data capacity. Next, we have the hard disk drive. It is a magnetic storage device installed inside the computer that is used as permanent storage of data. Storage capacity is measured in gigabytes or terabytes. The speed is measured in revolution per minute or RPM. So this hard disk is installed inside the computer. Next, we have the optical storage device. It's a storage device that uses lasers to read data on the optical media. Blu-ray disc, CD-ROM disc, CRR, and CD-RW disc. DVD-R, DVD-RW are some of the examples. Remember, when you say CD-ROM, it is read-only memory disk, while CD-RW, meaning to say that the RW stands for rewritable. Once you save data, you can still delete the data and replace it with another file. While the CRR or the CD-ROM, once you save it, recordable CRR, meaning you can record once. Once you use the optical storage device, you cannot delete the file and you cannot rewrite anything. Same thing with DVD-R, recordable. R stands for recordable, while DVD-RW, it's rewritable. So recordable, you can record, but you cannot delete the file that you already record. While the RW means you can still replace the file with another file. Flash drive memory devices. Flash drive is a portable storage device with 1 gigabyte to 1 terabyte storage capacity. It is used to store and transfer data between devices via USB port, Universal Serial Bus Port. So you are all familiar with the USB flash drive. Compact flash is a 50-pin connection storage medium commonly found in PDAs, digital cameras, and other portable devices. Memory card is a storage media that is often used to store photos, videos, and other data in electronic devices. Flash drive memory devices. We have the solid state drive, or SSD, is a storage device that is non-volatile. It holds and accesses data like a hard drive, but it has no moving parts. It is faster, noiseless, higher reliability, and lower power consumption. Processor, or CPU, is the brain of the computer system. It handles all instructions from mouse and keyboard and provides appropriate output. Video card. A video card is a hardware connected in a computer's motherboard that deals with processing images and videos. Now let's discuss maintain measuring instruments. Number 1, always follow the manufacturer's instruction and standard operating procedure in proper store usage and handling. Number 2, portable storage devices needs to be scanned using the latest virus scanner to avoid transfer of virus from one computer to another. Number 3, avoid touching sensitive parts like the magnetic disc, pin, and connectors. Number 4, blow away dust using compressed air. And number 5, use storage for small devices to avoid losing it. And lastly, do not drop to avoid damage. conversion, and calculation. Computers use binary codes 1 and 0 to represent and interpret letters, numbers, and special characters with bits. A decimal number can be understood by a computer if it is converted to binary first. So, you can read this figure as 805. This is still very visible to our digital clock. The 1 stands for on and 0 stands for off. Remember, all bits are on for the character 8. And remember, 8 bits is equal to 1 byte. Let's see how many bits are on and how many bits are off. For character number 5, how many bits are on? So we have 1, 2, 3, 4, 5. These are all equivalent to 1 because they are on. They are all visible. Now, there are 3 bits off for character 5. For character 0, there are 4 bits on and 4 bits off. Look at character 0 now. Now, let's convert decimal to binary. To convert decimal number to binary, divide the number by 2, get the quotient and remainder. For example, we have a decimal number 45. What is the equivalent of 45 into binary number? So, 45 divided by 2, our answer is 22. And the remainder is 1. 22 divided by 2 is equal to 11. Remainder, 0. 11 divided by 2 is equal to 5. Remainder, 1. 5 divided by 2 is equal to 2. Remainder, 1. 2 divided by 2 is equal to 1. Remainder, 0. 1 divided by 2 is 0. Remainder, 1. Now, to write our answer, we're going to write from down, from bottom, going up. So, it will be right as 1, 0, 1, 1, 0, 1. Okay, binary number. So, this time, we are going to check your work. The given number is binary, convert to decimal. So, the process will be multiplication. Okay? Multiply by 2 because the given number is binary. So, binary means 2. Always use 2 if you are looking for binary, if you're going to convert to binary. Then use the power of the decimal. So, means you start from 0 to, the accepted numbers are 0 to 9. So, let us rewrite 1 times 2 raised to the power of 0 is equal to 1. Rewrite 0 times 2, this time raised to the power of 1. So 2 raised to the power of 1 is 2. But 2 times 0 is 0. Next, 1 times 2 raised to the power of 2. 2 raised to 2 is equal to 2 times 2. You multiply 2 into 2 because it is raised to the power of 2. So that is 4 times 1 is 4. Next, 1 times 2 raised to 3, meaning 2 times 2 times 2. That is equivalent to 2 times 2 is 4 times 2, 8. 8 times 1 is 8. Then, bring down again the 0 times 2 raised to 4. 2 raised to 4 is equal to 2 times 2 times 2 times 2. So that is 1, 2, 4, 8. That is supposed to be 2 times 2 is 4 times 2, 8 times 2, 16. But 16 times 0 is 0. Next, we have 1 times 2 raised to the power of 5. 2 raised to the power of 5 is equal to 2 times 2 times 2 times 2 times 2. You multiply 2 into 5 times. So that is 32. You add all 32 plus 8 is 40 plus 4. 44 plus 1 is equal to 45. Or you can solve it this way. This technique is more faster. So, given the number, binary number 101101. Okay, always remember to start from right going to the left. Right going to the left. Okay, so 1 raised to 1. After 1, 2. After 2, 1, 2, 4. After 4 is 8. 8 times 2, 16. 16 times 2, 32. Always multiply by 2. Again, 1. Then 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. If you have another binary number on the left side, the farthest left side, so that is 32 times 2, 64. Okay? So that is to the nth power. Meaning, walang katapusan. Because we are talking of binary numbers. Okay. So, get all the value of 1. What are the numbers that has a value of 1? We have 32, 8, 4, and 1. Disregard the value 0 because it has no value. It's 0. So the total is 45. It's the same, okay, with the first technique. When it comes to text and characters, there is what we call an American Standard Code for Information Interchange, also known as ASCII characters. So each character has a code. So For a character space, for space, the code is 32. For a character of letter D, capital letter D, the code is 68. Look for capital, for small letter or lowercase letter A. You have a code of 97. Okay? So, all characters has a code known as the ASCII code. Now, let's try to solve this. By using the ASCII to decimal table, let us convert the word hello into binary. Okay? H is equal to 72. E is equal to 101. 1 is equal to 108. Oh, L is equal to 108. O is equal to 111. If we are going to convert 72 to binary, let us convert 72 to binary. How will you do that? You are going to multiply. Okay, let us check. Okay, you're going to divide. I'm sorry. So, 72 divided by 2, that is equal to how many? Let's use the calculator. 72 divided by 2, 36 is the answer. So, our remainder is 0. Okay, 36 divided by 2, our answer is 18. Remainder, 0 again. Okay? 18, remainder 0. Next, 18 divided by 2, the answer is 9, remainder 0. And then 9 divided by 2, our answer is 4, remainder 1. 4 divided by 2, the answer is 2, remainder 0. And then 2 divided by 2, the answer is 1, remainder 0. Can we still divide 1 into 2? You cannot divide 1 by 2. So, our final answer will be 1, 0, 0, 1, 0, 0, 0, 0. Again, our answer is 1, 0, 0, 1, 0, 0, 0. Now, try to check your answer again. This time, you rewrite 1, 0, 0, 1, 0, 0, 0. So, get into 1, 2, 4, 8. Power of 1, 2, 4, 8. 16 times 2, 32 times 2, 64. Okay. So, get all the values of 1, which is 64, plus 8, that is 72. Plus, another value of 1 is there any value of 1? Wala na. Yun na. 64 and 8 lang. You add 64 plus 8, that is 72. Did you get this? Did you get the binary equivalent? Okay, same thing with the decimal equivalent of letter small e. Okay, the small e has a code of 101. So all you have to do is to get the final answer is divided by 2 until you cannot divide 1 anymore by 2. Okay, until you reach 1 divided by 2. You cannot divide that anymore. So, to get the equivalent of hello, the word hello, capital H, small letter E, small letter L, small letter L, and small letter O, the equivalent binary code is 100, 1000, and 1100, 101. And for small letter L, 1101, 100. And for small letter O, it's 110, 1111. That is the equivalent value of character hello in binary code. I hope you understand the conversion. Again, capital H is 72, small letter E is 101, small letter L is 108, and small letter O is 111. Have you ever wondered how many files can be stored in your storage drive? There is a way to know file storage capacity. When referring to storage space, we use the term bytes or capital B, kilobytes or capital KB, megabytes or capital MB, gigabytes, capital GB, and terabytes, capital TB. Remember, a bit is only 1 or 0, meaning on or off. Nibble is equivalent to 4 bits. And when you say 1 byte, it means 8 bits. To have a kilobyte, we need 1024 bytes. To make 1 megabyte, you need 1024 KB or kilobytes or 1,048,576 bytes. For 1 gigabyte, the equivalent of this in MB is 1024 megabytes or MB or 1,073,741,824 bytes. 1 terabytes is equivalent to 1024 gigabytes or 1,911,627,776. So it's easy to remember the 1024 bytes for 1 kilobyte. It's easy to remember 1024 kilobyte to have 1 megabyte. And it's easy to remember 1024 megabyte is equivalent to 1 gigabyte. And lastly, 1024 gigabyte is equivalent to 1 terabyte. First step is to determine the size of your file. Then, identify the size of your folder or storage drive. For example, a file size is 45 kilobyte. 1 kilobyte is equal to 1024 bytes. So that is 45 multiplied by 1024 is equal to 46,080 bytes. So a folder size is 1 MB. 1 MB is equivalent to 1024 kilobyte. Gigabyte. Okay, GB. So 1,048,576 divided by 46,080. Saan mo nakuha yung 46,080? We simply multiply the 45 KB times 1 KB. 1024. That is 46,080 or equivalent to approximately 22 files can be stored in 1 MB. Another example, if you are wondering how many photos can be saved in 1 gigabyte USB flash drive. You have a USB flash drive, okay? And your USB flash drive has a capacity of 1 gigabyte files only, bytes, okay? So, how many photos you can save in 1 gigabyte flash drive? Suppose a 1 photo is equivalent to 5 MB. Okay, we're talking of MB, ha? So, 5 MB times 1,048,576. That is equivalent to 5,242,880. So, meaning to say, 1 gigabyte is equal to 1,073,741,824. However, we are going to divide the 1,073,741,824 into 5,242,880. So, if we're going to divide that, our answer will be 204.8 photos. More or less, depending on the actual image size. Are you ready for your learning task 1? Okay. Convert the following numbers and words into binary digits. Perform checking to verify the answers. Write your answers on your answer sheets. For number 1, 45. What is the equivalent of 45, 37, 12, God, and love? 2 binary numbers. You may use the given ASCII code that you screenshot. Okay? The ASCII code that I gave you. I will give you a minute to answer this activity. that is 101101 binary. Base 2. 37 is equivalent to 100101 base of 2. 12, 1100 base of 2. Okay, for letter G, the equivalent of binary is 10001111. For small letter O, that is 1101111. And for small letter D, it is 1100100 base of 2. For love, capital letter L is equivalent to 1001100. Lowercase o, 1101111. Lowercase b, 11101110. Lowercase e, 1100111 base of 2. Did you get it all correct? If not, it's okay. You go back to the video. You review this video once again. And you will learn how to convert or how to get the binary equivalent to the ASCII code that I gave you. For your learning task 3, identify how many files can be saved in a 5 MB size folder. Suppose you are given a 5 MB folder, 5 MB only, ha? So, how many files created from Microsoft Word you can save? If one file contains 20 kilobytes, one file is 20 kilobytes in Microsoft Word, how many files can you save in a 5 MB folder? Number 2, how many pictures you can save if each picture is 2 MB. Per picture is 2 MB file. So you are only given a 5 MB or megabyte of folder. Okay, I will give you a minute to solve this problem. Your timer starts now. I would like to share a quote from Albert Einstein. Education is not the learning of facts, but the training of the mind to think. So, what are you waiting for? The time is now. Train your mind to think for your better future. Again, this is your teacher Berna saying goodbye and God bless you all.